All right. Hi guys. So it's been quite a while. Okay, I think it's been like 3 days since I last streamed. Um, I was out for my birthday for the most part, and I also just wanted to take some time to like not relax, but kind of sit down and consider like what I want to do going forward. But I also did some off-stream work as well for the last few days. So, yeah, the stream says like day 30, but I'll be honest, it's like kind of a lie. Realistically, this is like day 36 or something. Um, it's just that like being in the airport a lot of the time in the past few weeks, not weeks, but like last week and a half, and also in a few weeks going forward, I'm gonna be flying out again. But there's really no clear time slot to have like a reasonable stream. I mean, I totally could, but I decided to celebrate with family and just relax for like a couple days. But I'm back in it. But I do want to start off by talking about, well, I'm going to start talking about a couple things. But starting off with what I've been doing for the last week. So, as you can see, um, I have my codex, which I installed for not a long time, but maybe like 2 weeks ago, week and a half ago, and I successfully implemented an auto research loop, which is really, really amazing. I'll go. It's done a lot of progress for me, and made things a lot easier while I do my own things, whether I'm hanging out with friends or I'm sleeping, or even working on other technical work that I don't stream. But really, what's going on is that for I think the past 48 hours almost, not yet, but almost 48 hours, Codex has been running a bunch of experiments on its own, and I restricted its context to two files that, in my entire project that kind of contain all the hyperparameters and also the model architecture for different experiments. And I've been trying a lot of different things for the last like month when I was tuning the model, and there was a certain point where I kind of realized like, okay, I mean, there's not really anything major I can do. Um, Maybe there is, but I've done a lot as much work as I can, and there's not really anything different about the model that I can make. And I mean, yes, there could be, but I could be adding like a bunch of more parameters for no change. And so I'm a big believer of simplicity and model interpretability, and being able to understand what exactly your model is doing, which kind of ties in with keeping it as small as possible, is good while still making really accurate predictions. And so I am a big believer in that regard. And so that also, like with that in mind, that also involves a lot of small tests that, well, as you can see in previous streams, that I run and then end up discarding. And I've come to the realization that, like, yes, I do have ideas, but it's just, it's very tedious. And I remember seeing this Carpathy auto research loop like a few months ago, and it kind of shocked, not shocked, but it really became popular among the tech community in the sense that, like, it's like, oh my god, like top AI labs trying to implement this one single thing that could make a bunch of researchers and research engineers' lives easier, just got open sourced and released for free to the public, to the entire world. And a bunch of AI labs have been trying to do it, and Carpathy just like released it, and it's changed the game since. And so it's always something that I've been wanting to do, and I really wish I could have done it on stream, but it honestly didn't take the longest. I think it took around like 3-ish to 4 hours to set up a couple days ago. But I can talk about exactly what's been going on. So okay, right now there's a few things that actually I can just talk about it right now on here. But let me stop the auto research thing right now. Um, as you can see, these are the list of all the experiments that it's ran since the last 48 hours, and I did not touch my keyboard nor did I touch my mouse pad a single time since. Well, besides for doing my own thing on this laptop. But as you can see, this top point right? This baseline experiment was pretty much the best version of the model, or I wouldn't even say model, like best version of the entire project that I've had, and I've been trying to improve since. But honestly, I even talked to my advisor, and I just like scrapped like the ideas of putting in as much effort for something that might not actually change anything. And yeah, so it's been around this. Now it's not this specific number. This is like a specific loss value at a certain point in the experiment, which I'll get into later. But all you need to know is that I pick a specific point within the training run, and these are all like the loss values at that specific point, and you just compare the state of your experiment to other states. But yeah, so this was the baseline, right? And me doing like my own thing couldn't get any better. And so I let Codex like run a bunch of different things. And I'll get into how. But essentially, it made a bunch of changes. And then if it made another change but it didn't improve it, it would discard it. But if it improves it, then it would keep it and then build off on top of that change. And if you keep going all the way down, there's mostly discards, which makes sense. Like, I honestly don't see this model getting that much better. But now at this point, like relative to the decimal places, like after 3.6, the loss severely decreases. And I have a nice like graphic that I did make before the stream. I actually made it yesterday when I was showing it to like my friends. But here it is. Okay, yeah. So this scale, right? I don't forget about the x-axis. The x-axis doesn't really matter. It just needs to be the same in terms of like width between steps, because there's no like time or epoch. Like, this is not based on training time. This is just based on the number of training runs there were. And so this was like I decided to plot like all the major changes where it would say keep, but I never plotted anything that says discard, since, well, I mean, intuitively you would discard that point. But yeah, so this top point that I on the red at the very top was basically like the state at which I was stuck at for basically this entire month, and there was just no improving it, right? And in just 48 hours, Codex just severely decreased it, like to the max. And I think there was a point where I actually tried running a test run on my own outside of Slurm Jobs, if it was like around here, and a single, like, I'm running on the HEC 293 cell line so far, because like it's one of the benchmarks that other papers in the field report. And the PCC, the Pearson coefficient, it's not like it gains like it twofolds, right? I mean, even at this point, it's actually impossible. But it kept increasing, and I could see, like, based on the training graphs, like training is way more stable, and it even got my best run, which was like, wow, like I'm just not doing enough, I guess, right? And there are a few things on the list of changes that Codex had made, but and some of them like I knew, and I've already tried myself actually, and so like a lot of these discards are something that like I already tried on stream, but I guess it's just like it's my fault for not logging it and telling Codex what I've already tried, but that's fine. Like, I might as well just let it do its own thing. But there were also a few things that I actually just like a few pre-training techniques that I didn't even know existed. I'll be honest. They were like very, very specific. CELU residual activations. Like, I did not know what that was coming into this, and this is very specific and very niche. But honestly, like what I've from my experience and like looking at the changes and like what Codex specifically changed, I think the best like rule of thumb is like when you already have like huge ownership of your project, a lot of it comes down to how like general and how niche like your changes are, and even before you see what the results are, you can kind of get a sense of like, will it work or not. So I mean, yeah, like I did not know what this was like ever in my entire life, but it's like this just is so specific, like there's just no way it would make a specific like a significant change, right? And surprise surprise, it discarded. But there's some general changes that like I actually didn't even like think about, where For example, okay, um, extending the cosine horizon, right, for the early stoppage. I mean, that was something that was there, but I just never touched it. Not for a specific reason. It's just that there's so many other things that I've been trying out that I just never really got to it, and it actually improved training. Um, and then also just changing the number of groups in the group norm. So if I hold on, I'm in Tmux right now, which is nice. Uh, here. So yeah, these group norm layers that I have in my dilated convolution block, I never actually changed the number of groups. I just defaulted it to 8. I mean, it's just a nice number. I have a batch size of 32 right now. And that's the maximum it can be. I've already tested 64. There's not enough memory in my system for my virtual machine, so it's just 32. Keep it at that. And I never touched it, but Codex found out that you can actually increase the number of groups, and when I increased it to 16 instead of 8, it improved training significantly. And that 8430, it's let's see, where is it? Yeah, it's this purple point right here. So you can see that, like, okay, here there's like a significant jump between blue and green. And what was that? It was this change right here, right? And so it's just an example of things that like AI would like automatically look at, that maybe us humans, like, even if we know these types of things exist, we might not just get into it because we're just so busy with so many other things in the project and in life. And so that's like a very eye-opening thing. But yeah, that's pretty much it. And okay, so I'll also get into like how this entire like auto research thing works. So if I go into Karpathy's auto research GitHub, so he kind of explains it here, but essentially when he was playing out around with it, so he uses Claude code for it. And I think that was kind of like a foreshadowing of what was going on with the actual general tech world and the talent poaching, where he joined Anthropic very recently and hasn't really made a commit on his GitHub since then. Call me a stalker, sorry. But he was optimizing in a small LLM, and so there are a few components. I don't know exactly how many, but I can just start listing them off. One, the most important thing is you need an MD. It's like a README, but he calls it a program.md file for your agent to look at before it looks at anything else in the code base. And it's that single text file that's going to basically determine your entire experiment, how you want to run the experiments, and what you want to do. And you can specify your goals within that. And so if we take a look at it, yeah, so he has it in this format, and this was so good. Like, this was like a lifesaver for me, in the sense that I didn't have to like write my own, like, obviously I had to write my own instructions, right? But I didn't have to like spend time thinking about like, okay, how do I want to prompt, because I'm not a prompt engineer. I'd like to be one. I think it's an important skill no matter what field tech that you're pursuing. But I just didn't know exactly where to start. I just knew that you needed a program.md file for your agents. But he gives a template right here. It's not, I don't know if I haven't talked to many people about auto research, so I don't know if like this is the conventional template I should use, or if there's like an even better one. But I just simply went into the code and then I copy pasted this entire thing. And then I just like scrapped parts that I didn't need. Like when I was talking about different stuff about the LLM or certain goals that he had, I just scrapped it and replaced it like with my own goals with reward miss. And so that was that. And so if I go into my goals.txt, okay, so yeah. Oh wait, no, that's not it. Oh yeah, and if you can see here actually, yeah, this is Codex doing its thing. It scored. Okay, yeah. So right now it's playing around with like the max epochs, which I don't know exactly why. Now that I think about it, I don't know why it's doing that, and it shouldn't matter. I guess I did tell it to play with its own with any of the hyperparameters, and they're all fair game, so it's fine. But anyways, going back to what I was saying, like, yeah, you can see that it's tracking the changes that it's making, right? And there's a new loss here that's recorded, and it updates this results.tsv file, which I'll get into later. But going back to the program.md file, so program.md, right? I copied almost exactly, what Karpathy did, and yeah, so you start with auto research, right? And that's, I can honestly, this title does not matter, but he predefines the goal. So not the goal, but a brief description of what the experiment is, and it's, in his case, have an LLM to do its own research, but in my case, to have the LLM do its own research on reporters. I don't know. I don't think it matters too much, I'll be honest. But this setup is very important. So there's a specific run tag that he has. And when you have your own repository for your project, one important thing that I never even considered about when I thought about auto research, but Karpathy does, is having your own branch for your own experiments, which, yes, in the grand scheme of things makes sense, but I always came into this, or thought of auto research as this process where you don't even touch the Git workflow at all. You're just having it do its own thing because you're restricting it to just one file. And honestly, I think it does make sense in the grand scheme of things. Maybe even if you make changes, right? Because I always thought it's okay if it makes significant improvements and then you review the code, you can just push or commit those agent changes on your code base and then just have that as the main branch. But if you're making, if you have a team of other researchers or developers and you're working on this bigger project, yes, now it does make sense. So yeah, it's really smart though, because you can actually specify hey, right, essentially all you need to know is you're telling the agent hey, if you make a new change, right, and it actually improves, commit that change to it or at the end of the experiment, right? And so right now I've been on one experiment, so it actually hasn't committed to it yet. But yeah, and so that Git workflow is very important. But the other part is also this, right? So when you initialize your results, if I go back to this stuff right here that I'm highlighting on my screen on the right side is basically all the results, right? And I talked about this before, but this is something that not many people might not initially do when they're thinking about auto research and they're just letting the agent do its thing. But having an organized system of okay, what improved, right? How much did it improve, and what did you also try that failed? And that's very important. And so you have that TSV file along with the program.md. So two things. And then the other thing, there's another third component where you have a specific timer. You have a specific timer on how long each experiment is. And I think that's also very important. I want to look into how to find the optimal time, but Karpathy in his case actually had it so that his training runs and his little experiments that the agent would do on the LLM would have I think a time frame of 5 minutes. So yeah, so by design, training runs for a fixed 5-minute time budget. That's the other component about that. That's the third big component, right? So you have your program.md file, which is just your set of instructions describing the experiment and telling the agent basically everything on how to run a specific experiment. And then you have your results log, which in this case, I'm using a results.tsv file, but maybe there's other better ways. I don't know. I can look into that in my own time, right? You have your results log, and that's the second thing. And the third thing is your timer, right? This timer is very, very important. In PyTorch, right, there is a nice little thing that I can use to, I think it's train.py, where you can set the time. So here, right, where is it? Hold on. Oh, okay, there we go. Yeah, so when you import time, which is a Python library, you can actually clock how long your, like, when you run the file, how long it takes. And if it takes like 5 minutes, then the agent, you have to prompt the agent in your program.md file, like you have to stop it, right? You cannot let it continue. Maybe there's like another, I don't know, if you're in an infinite loop, right? It might not know that, right? So you have to explicitly tell it stop the experiment. So that's the third most crucial thing. And so for me right now in my case, because loading all the transcripts in the data, it takes a bit of time. So I have it set to 10 minutes, and then for like extra cushion, I have it set to 15 minutes. But it's also easy for me because in my slurm command for train, it's really simple. It's literally just conda activate orthris, which is my environment, and then you have python scripts / train.py. That's it for me. And so I can actually hard code the time of how much like time I have in that compute node for a certain job. And so that it made it easy. I have it set to 20 minutes, but I can honestly decrease it down to 15, like I have it in the prompt. But yeah, that's pretty much what auto research is doing. I know I'm not the best explainer, right? So anyone that does end up watching this video, I don't know when that would be or if anyone would, but you just have your instructions for your agent, right? And then you have your results log, and then you have your timer. You have those three things, then you can pretty much do anything that you want, almost anything, right? Because overall, right, as long as you have a metric, it doesn't matter, even outside of AI, right? As long as you have a metric that's quantifiable, that you're trying to optimize, then you can run auto research on any of that. And so for my case, in my case, I'm trying to train a model to reconstruct the RNA and ribosig profiles. So how do you quantify how good a model is doing? Loss. And so if you're trying to optimize, and loss is quantifiable, so if you're trying to optimize that, then that's your metric. So yeah. Yeah, I don't think I need to go too in depth of like what I'm specifically doing in terms of like, oh yeah, how did I write the program? It was literally just copy and paste Carpathi's program empty file and then replace it with my own things. His way of running things is completely different on mine, but it's pretty much the same thing. So yeah, that's that. And one thing is also, he suggests that you have one file to edit. I have 2 files to edit, and it's still working completely fine for me. So yeah, I'm gonna try and stop auto research, and then that will take me to the next thing I want to talk about really quick. Okay. I could do /thought, right? So, hold on. I'll wait for this training log to finish, and I'll stop it. But yeah. Hold on, I'll be back. I just need to wipe some of the coffee bottle on my table. Oh yeah, and I'll also be ending stream relatively early because there's a chess tournament that I want to attend, and I'm also hanging out with some friends later. We'll see. Actually, I don't know. I'm thinking about it, but it's at 7:30 at my time, so 3.5 hours before that. So there's still a bit of time to knock out good amounts of work, and also finish talking about my plans. Um, but yeah, this won't be the longest stream, but I am gonna be getting back into the grind. I'll just wait for a bit. Okay. It's completing right now, so that's fine. Okay, so it improved. That's nice. Look at that. Nice, nice. Um, let's see. 5, 6. With cosine 4. Okay, I'm gonna stop it now. Let's see. 16 epoch aligned. Okay, I stopped it. Boom. Stopped. You can stop auto research now. So what happened during? Okay. All right. Nice. So I stopped it almost 40 hours later. Let's go. So what I'm going to do is I'm going to go into a compute node and then run the current thing, right? So git status, which branch am I on? Okay, I'm on the auto research branch. So idef p I don't know how long this is gonna take, so oh no, it takes quick. That's nice. I don't know, it's taking time to. Alright. Cool. Zero to 2 hours, and then I'm gonna uncomment out my early stoppage. I need val PC. Okay. Stopped auto research. So the baseline was this, and then was that loss. So approximately 0.54%, but that's okay. Who cares? Nice. Okay. Two. Wait, what? Since you're reading it? Alright. Uh... Okay. Cool. I'm gonna submit a test run really quick. But I just want to see like what the current I want to see what the current run looks like. Alright, nice. Model type Aribo. No, yeah. Python, scripts, Pi. Default is Ribo, so. Wait, no. Hold on. One last thing I need to do. I'm gonna replace this with a star. So, I only ran auto research for this, but doing it for all files. Yeah. So we'll see how it goes. Okay. So now we have that. I want to talk about another thing while this runs. So part of the stream is also like talking about like not what I'm doing in research as well, but also like what my plans are forward. And so I might need my iPad for this. So I'm basically at the point, and I know I said this before, where like with my knowledge right now, I don't know how I can like advance my current project and also contribute to my lab, in the sense that I've been making a lot of progress, but now I'm like hitting this wall. And I've talked to my advisor, he doesn't know either. And he just told me like, no, sometimes you just need to read papers. That's okay. So, what is my plan in the next few weeks? I've been, depending on how a few things go, my personal goals will definitely change throughout the next semester. But I became so invested and interested in embeddings and latent spaces. So here, if I go back, right, I've been so invested in specifically Orthrus, not specifically Orthrus itself, but like what it does. And also the idea of foundation models, which I just have never looked at before. And what do I mean by that? Of course, like, I do think that drug discovery is a pretty big future, and it's something I totally keep on doing and reading into, regardless of like where I'm at in my career. But I do think that let's see. I do think I need to expand my knowledge on just general deep learning. And what do I mean by that? Like, not exactly what deep learning is, right? But I feel like I need to kind of go on this like training arc, quote unquote, or go on this period of within the next few weeks where I'm just stepping away from genetics and going back into like the fundamentals, the theory, and intuitively like how different researchers throughout history actually made their decisions and why they made their decisions, which is actually more important than what the decisions were and what led up to those types of decisions. And so what do I mean by this, right? I'm talking about like the fundamentals of like, okay, all right, for example, NLP, right? That's a very big thing, right? I strongly believe, for those of you that do keep up with like the news, world models will play pretty big role in the future. And so who's proposing that? Who started proposing that? Well, world models were actually something that were presented for the first time in like 2017 by some scientists, but then Yann started recently in the last few years started recently proposing like world models importance and why LLMs are not actually the true path to AGI. And so now we're starting to see some success in its application to robotics in early research with this. Now, it's not actually the industry standard, it's not being applied yet, but we're quickly seeing its success. And so, why do I bring all this up? Not because I want to talk about world models, but I want to talk about like exactly like it's that those types of decisions where great researchers like him actually like feel confident with their decision, but also it's those moments and scenarios that kind of define the trajectory of AI research. And this has been applicable to like pretty much any other decade and year when you look at like the history books of this type of field. And it's something I've never looked at into. I've only ever looked into the what, but I never actually looked into the why. And that's what I wanted, and that's what I'm talking about. I'm talking about like when the first neural network was made, and then when deep networks were made, CNNs. Then we started looking at sequencing data, temporal data, and then the development of RNNs and why they looked promising at first, and then they quickly became pretty useless later on for much larger tasks and more general tasks. But then we have LSTMs, and then eventually that led into the transformer, and then BERT on one side for the encoder, and then GPT for the decoder. All of those things, like those little steps, like I think I need to look into that. And so, how do I do that? I think I'm going to be spending the next few weeks going back into the basics. There are courses that I want to take a look at. And I think why now, like why this is such a perfect time for me, because I'm also, like I said, I want to talk about embeddings, look into embeddings, and to make better genetic models, I think I really want to explore foundation models, and to get better at foundation models, I have to understand embeddings and latent spaces to its absolute core. And me being a student at UAT, I've been trying to search for professors that really work in this space, but there was this one NLP professor, and I was telling my friend earlier that here's my problem in genetics. Here's what other people don't talk about in genetics and the potential of certain deep learning methods, this deep learning method in genetics, and here's like why I want to research it. NLP professor redirected me to she actually said she does not work on any of those types of things. She works on different applications of NLP. But she redirected me to this other professor in a different university who she like is fully confident that there's no one else in the world that understands that topic better. And so I reached out to that professor, and she actually responded to me like yesterday, which was very exciting. And so most likely I'm going to start doing a research project in that regard. But the big picture and the big goal for this is being basically the master at embeddings. And so I can apply all those techniques back into this genetic lab that I really enjoy. So that's that. Setting signal headers. Wait, hold on. Okay, so yeah, I'm basically just gonna be going into courses and starting from scratch, right? And again, this is also perfect because one, that extra lab, but two, other people in my lab or my advisor is kind of like busy, and he's out of like technical work for now. So we're just probably gonna like take a break and just focus more on like data analysis and processing, all of those sorts of boring stuff that I don't have to be too concerned with for now. Um, why is it taking such a while for all this to load? This is so annoying. Okay. Okay. Also, because for my student org, right, is I have to create like a curriculum, and I think going into courses and taking time to really study them is going to be a great opportunity for me to like refine my understanding, but also have better ideas on how to like give other students in our org resources to understand deep learning, because we are in an AI engineering org, and so I'm excited for that, and I think it's gonna look good. But I think what it's looking like for the next 3 or 4 weeks, it's like, yeah, I'll call it genomic AI ML research. I might not, but I'm gonna be touching a lot less on genetics and touching more onto theory and systems and how to make better systems and better architectures. And so yeah, that's my goal. But yeah. Okay, so yeah, that's the plan. So there's this one course that I want to look into, and it's actually all in the GitHub. And let's see, all I have to do is clone it, but we're gonna be starting from the basics. But why is this thing not working? Alright, I'm gonna be opening up VS Code. Where is it? Do I not have it? Oh, okay. Okay, so the log progress was removed. That's so annoying. That's so annoying. Okay. Oh, I see. Hold on. Ribo. Yeah. Okay. Alright. That's my fault. Okay, let me open up VS Code again. I don't know why I'm opening up OBS, but I don't know why it's impossible to. I don't know where VS Code is. That's annoying. Okay. I'm updating VS Code right now, but I'll get water and then I also have to put some dishes up. I'll be back really quick. Hold on. Oh, hold on. don't like this. This is AI slop, bro. Okay, there we go. Now it's back to normal. Okay. Nice. Nice, nice, nice. Um, okay. Nice. Wow. This is really good. UV. Okay. Actually, hold on. I've been doing it wrong. Okay, that's fine. I want to change this thing right here. It's like what, 7 million parameters or something? Okay. What the what? Hmm. Oh wow, this is really good. Wow. Nice. 0.553. Nice, nice, nice. Okay. Wow. Okay, I'm gonna look into what's going on. Moon down. Oh. Hmm. Kimmy code. Oh, I can't use Kimmy code. Hmm. One times credits. Okay, let me try this actually. Hmm. Oh, okay. There we go. Modified enter keys. That's fine. Hmm. Oh. What? Wow. Okay. 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 I think I'm gonna end stream here. I need to get ready for the day, but I don't know when I'll stream tomorrow. But that's the plan. I'll wake up early. Yeah, trivial work. I'm like a bit burnt out, but we'll see. We'll see how it goes. All right, I'll see you guys next time.